All right, so derivatives. Okay, so one more thing about derivatives of inverse functions. Here's some more of these terms now. If f is differentiable at every point on an interval, right? And df dx is never 0 on that interval, then f has an inverse, and the inverse is differentiable at every point on the interval. Okay, so let's just take this one part at a time. If f is differentiable at every point, then it has an inverse, and the inverse is also differentiable. Okay? Fine. But now, why does it also have to be that df dx is never 0 on that interval? Why? Right, because what does it mean that df dx is 0?
It means the slope of the function is 0, so when you're finding the inverse would be 1 over 0, which is undefined.
Right, it means there is a horizontal tangent, which means the inverse will be a vertical tangent, and the slope of a vertical tangent is undefined. Okay? Okay. So a lot of the like definitions, theorems, and stuff in calculus, you just have to read them. You see how I looked at it like one part at a time? When you do that, a lot of them are just common sense, right? Because that's what math is at the end of the day. It's just nature written in another language. That's what it is. Okay? Okay. So now, let's take a look at the derivatives of inverse trig functions. We're only going to do the derivative of inverse sine and inverse tangent, okay, for now.
Yeah, for now.
So, the derivative of inverse sine, arc sine, inverse sine of u is, it's not a trig function at all. Okay, so what's the derivative of sine of x? Cosine. And what's the derivative of tangent? Secant squared x. So you see how the derivatives of the trig functions are also trig functions, but the derivatives of inverse trig functions are not. They're algebraic functions. So the derivative of inverse sine is 1 over the square root of 1 minus u du, 1 minus u squared, times du dx. Okay? So, that means inverse sine of stuff, right? The derivative is 1 over the square root of 1 minus that stuff squared times the derivative of the inside, because from now on, it's all about the chain rule. And of course, you know, there has to be a condition because the denominator shouldn't equal 0. U, the absolute value of u has to be greater than 1. Because only then, right, will this not be 0 or negative inside the root, okay? Okay, the derivative of inverse tangent of u is 1 over 1 plus u squared times du dx, okay? Okay, so now, yeah. Okay, so now, let's find dy dx here, and then obviously we need to simplify. So this is the inverse sine of the square root of 2x. So what is u here in this function? 2x to the power of 1/2, right? So again, right, oh, look, so here's a good example. U is the square root of 2x. The derivative would be 1 over 2 root 2x times the derivative of the inside, okay? Let's do it the old way though. U prime, or let's do du dx. Let's be more elegant. Is 1/2 2x, yeah. Du dx. There is no du, it's du dx. Du dx is the derivative of u. Because what, okay.
Du dx of u.
Yeah. Because
okay, and so u is just
the inside.
Okay, to hold value inside of it. Inverse.
Exactly. U is just the stuff inside.
So when you're just doing like a normal function, how do you know? Sometimes the one thing I was kind of confused about is if you write dy dx or d dx. That's like
d dx will never exist on its own. It's like just saying plus with nothing else, like no numbers. It's d dx of y. So you could do dy dx, or you could do d dx of y. Those are okay.
because like I just like, especially when we did the like when we're trying to find like y prime, like when you started, you instead of writing dy dx, you write d dx, and then inside that there's dy dx
of y. Yeah, d dx of y. Yeah. Yeah, d dx is just an operator. So if you have d dx, it's like writing that. Just that division operator. It doesn't make sense without numbers in front and in the back. Yeah. Okay, so y prime here is going to be 1 over the square root of 1 minus root 2x squared times u prime, which is 1 over root 2x. Okay? So this is 1 over, okay, I have square root of 2x, and then I have the square root of 1 minus 2x. Okay? But now I need to combine the roots. So I have 1 over the square root of 2x minus 4x squared. Huh? It's 1 minus the square root of 2x squared. Okay. All right. Here, it's inverse tangent. All right, so let's go ahead and get started. The derivative is 1 over 1 plus u squared. So it's x over 4 squared times the derivative of x over 4 is how much? 1/4. Okay, so now this is 1 over 1 plus x squared over 16. Oh, you know what? Sorry. Times 1 over 4. So it's really like this. It's 1 over 4 over 1 plus x squared over 16. Now, to get rid of that 16, I'm going to multiply this denominator by 16. But then I also have to multiply the numerator by 16. So I get 4 on top, 16 plus x squared on the bottom.
Wait, why is the 1/4, why do you multiply it only to the top?
Because it's this times a 4th, right?
Yeah.
And so imagine if this was a whole number, right? This times a third, you would only multiply it to the numerator, right?
But usually you can do 1 times 4 in the denominator times the
You can still move it to the bottom.
Well,
you'll get the same.
When you do 1/2 times 1/3, that equals 1/6. That's why I'm just confused why it's not like that there.
So if you did bring it to the bottom, you would get the same. So if you did 1 over 4 times 1 plus x squared over 16, like this, right? I would still multiply by 16. So now I get, it'll cancel out here. So here, what is this? So let's do it this way. If you distribute, it's 4 over, what's this? X squared over 4, right? But now we don't multiply by, we multiply by 4 now. Okay? So now what do I have on top? 4. And in the bottom I have 16 plus x squared. So I would get the same thing.
Wait, why did you get, I
get that 4 in the bottom before you multiply by 4. Shouldn't that just be 1?
Here or here?
So right there, inside the parentheses, you have a 4 on the left side.
So instead of doing it this way, if I wrote it as
4 times, right?
here, 4 times.
Yeah, but see how that has a 1 in the parentheses?
Yeah, okay, so let me do let me do it again. It's 1 over 4 times 1 plus x squared over 16, right?
Yeah, that's what I get.
Okay. Distribute the 4. 1 over 4 plus x squared over
4.
Okay, but now I'm not going to multiply by 16 anymore. Now the denominator is 4. Yeah. So I'm going to multiply this by 4 and this by 4. So I get 4 over 16 plus x squared. Just get rid of the. Yeah,
I did 1 over 4 plus.
Did you get the same? Did you get this?
Yeah.
If you got this, it's cool.
Oh, I did.
Oh,
yeah,
but
that's just because I forgot the x squared on the bottom. So it would be yeah, actually, can I ask you about this? So, couldn't you say that before you multiply by 4, when you I said that it was 1 over 4 plus x squared over 4. Like I distributed that, but then I made it into 2 different fractions. Where
No,
like
you can't split them up. You can't split it up.
You can't split up plus?
No, you can't.
So
you
1
could
over
split
1
it up
plus
if it was reversed.
X is not the same thing as 1 over 1 plus 1 over x?
No. No. Because 1 over
then you can say
1 over 9 is not the same as 1 over 4 plus 1 over 5.
Yeah.
You can't split it up that way. It is not equal to it. I don't want some class to come in here and say I wrote some weird stuff. Okay. All right. Okay. So, and of course, it's nothing if there is not a particle motion problem, right? So a particle moves along the x-axis so that its position at any time t is greater than 0 is inverse tangent of square root of t. What is the velocity of the particle when t is 16? Okay, so v of t, first of all, is x prime of t. Okay. The derivative of inverse tangent is 1 over 1 plus u squared times the derivative of the inside. So what's the derivative of a square root? 1 over 2 root t. Okay? So here I have 1 over 1 plus t times 1 over 2 root t. And it's fine to leave it that way because technically that's not my final answer, right? Because I'm evaluating it at t equals 16. So v of 16 is 1 over 1 plus 16 times 1 over 2 root 16. So that's 1 over 17 times 1 over 8, 1 over 136. Okay? We're not given units for length, so we don't know what the units are. Okay, find an equation for the line tangent to the graph of inverse tangent of x at x equals negative 1. Okay? All right. Oh, this is example 5. Okay, equation of the line tangent to the graph. Okay, so what's y prime? Or what's dy dx? 1 over 1 plus x squared. So dy dx, 1, 2. At x equals negative 1 is 1 over 1 plus negative 1 squared. So 2 on the bottom, 1 over 2. Yeah.
Why is it x squared?
Oh, that's the formula.
No, but like, why is it x? Wouldn't it be 1? Wouldn't the derivative be?
Oh, so first it's 1 over 1 plus whatever that is squared times the derivative of that. Yeah, so the derivative is 1. So then okay. So now I want the derivative of, I have the slope, I want my y value, right? So y of -1 is inverse tangent of -1. And what is inverse tangent of -1? What is the angle for which tangent is -1?
No, it would be
Okay, so tangent is -1 at 3 pi over 4.
Yeah, but also.
But it's not in the domain. The domain for tangent, yes. Remember?
I like this.
Okay, so the domain for tangent, it goes from -pi/2 to pi/2.
Wait, can you go over all the domains again for sine and cosine?
So tangent goes from here to here only. Remember how we would draw these things?
It doesn't equal pi/2 or
No.
It doesn't.
And it doesn't include pi/2 and -pi/2. So remember how it was just these 7 angles here?
Oh, because they're both positive.
Yeah.
And then what's cosine?
So it's -pi/4. Okay, so let's do this one first. So here, y is -pi/4. So this is all happening at the point -1 and -pi/4. So the slope of the tangent, the equation of the tangent line is y minus, plus pi/4 equals 1/2 x plus 1.
Did you say 5 pi over 4?
No, because it's not in the domain, right? It only goes.
Only go this way.
It only goes from -pi/2 to pi/2. Remember on the.
Yeah.
So if you said 3 pi/4, yeah, tangent is negative at 3 pi/4, but 3 pi/4 is here, way past the domain.
Okay.
And so is 5 pi/4 and so on.
Wait, so how do you know it's -pi/4? Oh, because tangent can only go from pi/2 to -pi/2.
Mm-hmm.
But on the right side, right? Like from this side. Yeah.
Yeah. So if the inverse tangent is negative, then it's in this quadrant, positive in that quadrant.
And how about
Yeah.
what is it for cosine?
So you mean nauseous.
Sine, same thing,
And equals pi/2.
but it does include pi/2 and -pi/2. Okay, it includes them.
And then cosine is like 0 to pi.
And then cosine goes from 0 to pi.
I don't remember why is that again? Why is that?
Because
that's when cosine's at its max and min.
we have to do restricted domains. So remember.
Oh, because otherwise there's
Because after you go past that, it just repeats its domain, and then it's not a function. Like it
So
will
they
just
just-
start repeating itself.
They just pick those ones because they're closest to like
Mhm.
the axis.
Yeah. So sine of x looks like that, right? And if that's the y-axis, it doesn't pass the horizontal line test for it to have an inverse function. Okay? Just like this one. In order for this to have an inverse function, we got rid of half the parabola. We got rid of half its life. So here, we have to find a part that does pass the horizontal line test. And for that, it's from -pi/2 to pi/2. So we throw away everything else. Right? So it can't be 7 pi/3. It can't be 11 pi/2. It's just the angles from negative to positive pi/2. Okay? All right.
And all this history.
And a tortoise.
And a tortoise, and a bearded dragon, and a dog. It's a big family.
The Hyman family.
Exactly. You think
Okay.
I'm crazy. You should be my little sister.
Okay. E to the x. Okay.
What does that mean?
It turns out e to the x is one of the most special functions ever to find a derivative of.
It's the same thing.
So Okay, what is derivative, right? Derivative, remember we learned the definition of the derivative, and it was the limit as h approaches 0, f of x plus h minus f of x all over h. Okay, so let's do that for e to the x. Okay.
But isn't it just like a constant? No, never mind.
Okay, so e is
A constant.
a constant. E to the x, remember, is a exponential growth function. Okay, so now,
Did you say any number to the x? Like
yeah, later.
Okay.
Okay, so, okay, so d dx of e to the x, right, is equal to, when we use the derivative, okay, so f of x plus h, so e to the x becomes e to the x plus h minus f of x minus e to the x over h, and all this is when the limit of, as the limit of h approaches 0. So now, let's work backwards for a minute. If I have x squared times x cubed, what do I do to those?
You add them.
You add them, so it's x to the 2 plus 3. So if I had x to the a times x to the b, it's x to the a plus b, right? But now, okay, hang on. But now, if I wanted to go backwards though, if I had x to the a plus b, I could unravel it and I could write it as x to the a times x to the b, right? So, that's what we're going to do here. E to the x plus h, I can unravel it and say e to the x times e to the h, right? Because look, you see how this, when you add it, it'll be e to the x plus h? So now we just went backwards. Now look, you're going to have to do this all the time in later chapters, so it's a good idea to learn now. Okay, now look what we have. You have e to the x times something minus e to the x. You can factor out e to the x. And when you factor out e to the x, you're left with e to the h minus 1 over h. Now, okay. Limit properties say this. When you have the limit of something times something, right, you can take a factor out and it would be, you know, the same as, you know, like the limit of the, huh? You can take out whichever one you like, but here's the thing. Okay. When you take out e to the x and separate it, now you have this. Okay. This function, e to the h minus 1 over h, is something that shows up quite a bit. And now, everything in your gut is telling you, if I plug in if I plug in 0, e to the 0 is 1, minus 1 is 0 over 0, that should be 0 over 0. And that's fine. But what does 0 over 0 mean? Does it mean it's the end of the world? 0 over 0 is called what? Nope. Nope. It's not undefined. It's called, listen, 0 over 0 is called indeterminate form. 0 over 0 is called indeterminate form. That's what we learned way before, and we'll see that again. So listen, that means when you get 0 over 0, you can rationalize, you can do things, and so on, and in the end, you could end up with an actual value, okay? So here, the limit of that, if you do some math, which we're not going to, the limit of that in the red is actually 1, right? Because 0 over 0 is indeterminate, it's not undefined, which means the derivative of e to the x is just e to the x. That's it. That's the biggie. Yeah.
So I thought it was if you have the limit of something times something, like when you put something in front of the limit, like when you take it out, I thought it had to be a power.
No, it could be anything. It's f times g. So if you have the limit of f times g, you could pull out anything you want. There's no rule.
If it was like all of it to like a power, then you could have the power. Like, or is that something else?
That's something else. You're talking about factoring.
If you took out the other function, if you took out the whole EDH minus 1 over h, then you'd have nothing to plug in h to. Because you'd be left with just EDH.
Right, but that's the thing. You can't pull that out because then, just like you're saying, you can't. Yeah. Okay. So now, going back to the chain rule. Okay. So the derivative of e to the x is just e to the x, which means if it's e to the u, right, then the derivative of that is e to the u times du dx. So let's do a couple. dy dx of this, right? So dy dx of e to the, of ddx of e to the 3x. Well, the derivative of e to the anything is e to the anything times the derivative of u, which is just 3. So this is 3e to the 3x. Okay? All right, here, dy dx, e to the x plus x squared. Yeah. You'll see any constant. We'll do that in the next page. E to the x plus x squared times the derivative of the inside, 1 plus 2x. And it's customary to not write it like that, but put the algebraic function first, like this. Okay? Notice where parentheses are necessary, right?
You don't have to write like 2x plus 1. You don't have to change that.
No. Okay, now, this is e to the x. So now, the same question, right? I've been getting the same question already. What if it's any number to the x, right? So what if it's like 3 to the x and not e to the x? What now? Okay, here's the deal. If a is positive and it's not equal to 1, right? Because anything, if it's 1 to the x, then it's pointless. We can use the properties of logarithms to write a to the x in terms of e to the x. Okay, I'm not going to go through exactly how we do this, but a to the x, it can be written as e to the x ln of a. Like that's a property. Remember how like ln is logarithm, base e, and so on. So you could do that. If you change the base LA of a to an e, you could do it that way. So then we can find the derivative of a to the x using the chain rule. So look at this. If a to the x is e to the x ln of a, then let's do chain rule. The derivative of this is the same thing, e to the x ln of a, times the derivative of x ln of a. What's ln of a? It's a number, right? Like ln of 3 is a number. So the derivative of x ln of a is just ln of a. Okay? So then, remember how we had said that this was just a to the x? Finally, what we have is the derivative of a to the x is a to the x ln of a. Does that work for e? Can you say the derivative of e to the x is e to the x ln of e? Ln of e is 1, right? So that also works for that. Do you have to know how to come up with this, how to derive this? Not in the least bit. Just remember that the derivative of e to the x is a to the x ln of a. And then, if it's a chain rule, then it's the same thing, a to the u ln of a times the derivative. Okay, so let's do this one. Yeah. It's not as tough as you think because you use them so often. Okay. At what point on the graph of y equals this, does the tangent line have a slope of 21? So that means I need to find the slope and set it to 21. But what is slope? It's d dx, right? So y prime is equal to, okay, what's the derivative of 2 to the t? 2 to the t ln of 2. Okay? Minus, what's the derivative of the 3? 0. So that's it right there. And so now I need to set this equal to 21. Okay? Now, divide by ln of 2. This is algebra 2 now. 21 over ln of 2 is 2 to the t. And then what? Let's take ln of both sides, right? Let's take ln of both sides. So ln, ln. So this will be ln 21 over ln of 2 equal to, the t will come down, t ln of 2. And then this is, uh-huh. Uh-huh.
Like, how are you allowed to do that?
How are you allowed to do what?
Like, take out, like, one, like, over here, how are you allowed to take out, like, a whole part of the equation?
Don't worry too much about it. Yeah. You'll never be asked.
Just for the two equations,
Uh-huh.
I'm confused like when you know to
Oh, between these two?
yeah.
Okay. Yes and no. So this one is if y is, let's say, 2 to the x.
Okay.
This one is chain rule. So if y equals 2 to the x squared plus 1, right? Then you would do 2 to the x squared plus 1 times ln of 2 times the derivative of the exponent. Does make sense. It's math. Right? Okay. All right. So I will stop here and then we'll do ln of x tomorrow.